Jai Hind everyone. My name is Anupam Kumar, Assistant Professor, AKGEC, Ghaziabad. Today I am discussing here graph and their types. This topic is in discrete mathematics and data structure also. BTech second year, discrete structure and data structure. Topic covered definition of graph, various types of graph, terminology and graph representation. Various application of graph are computer networks, distinguish between two chemical components with the same molecular formula but different structure, solve shortest path problem between cities, scheduling exams and assign channels. These are various applications and many other applications where apply. Basically, graph has two main components. First component is vertex V1, V2, V3 and V4. These are four vertices, and edges which connection between two vertices. V1 to V2, there is a one edge that we name it E1, V2, V4, V1 to V3, V3 to V4, E2, E3 and E4. So here number of vertices are 4, that is V1, V2, V3 and V4. These are two vertices here, and edges E1, E2, E3 and E4. These are four edges in this graph. A generalization is simple concept of set of dots, lines, edges or arcs. Simple definition of graph is a set combination of vertices and edges. Graph G equal to V and E consists set of vertices denoted by V or by VG and set of edges E or EG. I write here E for edges, V for vertices, and number of vertices in this graph G is V1, V2, V3, V4 and edges are E1, E2, E3 and E4. This is the simple definition of graph. There are various terminologies used in graph. First one is directed and undirected. Directed means there is a direction shown between two vertices is U to V or edge, that is direction from U to V. And undirected, there is no any direction between two vertices and edge has no any direction. If we put a direction, then it becomes directed. Next, simple graph. Simple graph consists of vertices, a non-empty set of vertices and edges, a set of unordered pair of distinct elements of V called edge. Then graph G, V comma E. G represents graph, V represents vertices, E represents edges. Then there is a three vertices U, V, W and edges UV, U2 V, one edge, V2 W, other one edge and U to W, another edge. If we labeled these edges E1, E2, E3, then edges labeled by name, then we know UV as a E1, VW as a E2, and E3 VUW as E3. Next type of graph is multigraph. In multigraph, if there has more than one edge between two edges, if there is two edges between two vertices, here for example U and V are the two vertices, one edge is E1 and another edge is E2, then these are the parallel edges. For another example, if a graph if a graph of four vertices V1, V2, V3 and V4 and edges 1, 2, 3, 4, 5 and 6. These are 6 edges in a graph and 4 vertices in this graph. Vertex 5 and 6 are parallel to each other. Parallel means both vertices are common. If both vertices are common between two edges, then these edges are known as parallel edge. Then a multigraph have parallel edges. As we see, the definition consists of set of vertices V, set of edges E, and the function from f from E to UV, VU not equal to V. The edge E1 and E2 are called multiple or parallel edges. E1 and E2 are called multiple and parallel edges. In multigraph, parallel edges are allowed. Next topic is directed graph. As we know, there are edges with direction and edges without direction, as we see previous slides. Then directed graph is the graph in which edges have direction. Here one graph is shown. U, V, W are the vertices of graph. Edge 1, 2 and 3 are edges. Every edge has the direction H1 U to V, H2 V to W and H3 W to U. Then this graph is, if in simple way we can say, if a graph with directed edges, then the graph is known as directed graph. Various terminologies used in graph. First, degree of vertex. Degree of vertex is the the number of edges incident on particular vertex is the degree of vertex. For example, this graph G have vertex V1, vertex V2, V3 and V4, V5, V6. V7 also. In this graph, this is a whole graph G in which 7 vertices V1, V2, V3, V4, V5, V6, V7 are the 7 vertices in this graph. We count degree of vertex, that number of edges incident on particular vertex. If we count degree of V1, then number of edges at V1 is 2, 1, 2, 3, 4, 5, 6, 7. These are 7 edges. At V1, edge 1 and edge 2 are incident at V1, then degree of V1 equal to 2 and degree of V2 equal to 3, as we see that 3 edges are incident at V2, edge 1, edge 4 and edge 5. If there is any loop at a particular vertex, for example, we put a edge 8, edge at both, if both endpoint of any edge at a particular vertex, then it create a loop. Then it counts degree twice, as see a loop contributes twice to a degree. Then if we find the degree of V6, dV6, then there is a loop of edge 8, then it's 2 and one edge incident at V6 is 7, then total degree of V6 equal to 3. If we find the degree of V5, 1, 2 and 3, same as degree of V3 is 3, degree of V4 is 2. Next, pendant vertex. If degree of any vertex is 1, then the vertex is called pendant vertex. Here V8 have degree 1, then V8 is called pendant vertex. And isolated vertex whose vertex degree is 0, then it is known as isolated vertex. Here V7, degree of V7 equal to 0, then it is known as isolated vertex, because there at V7 there is no any edge incident on that particular vertex V7. So degree of this vertex is 0, then whose degree is 0 is called isolated vertex. Next, loop. As I discussed in previous graph, loop. A loop is an edge whose endpoint are equal, that is an edge joining a vertex to itself is called loop. Represented U, this one edge E1 is a edge which perform a loop. Both endpoint at U. Two vertices. More than two edges between two vertices is multiple edges. If there are more than one edge between two vertex, more than one edge between two vertices, then it is known as multiple edges. So, for example, this is U and B. There are 4 edges, and these are called multiple edges. Next, terminology used in graph is in degree and out degree if there is a directed graph. In degree means degree of vertices that are inside of the vertices, in degree number of edges for which u is terminal vertex, and out degree number of edges for which u is initial vertex. So, in degree of u, if we see that in degree of u is nothing and out degree of u is 2. In degree of v is 1, in degree of v is 1, out degree of v is 1. In degree 1, out degree also 1 are there in direction shown between complete graph. A complete graph is a simple graph that contains exactly one edge between each pair of distinct vertices. Means कंप्लीट ग्राफ वो ग्राफ होगा जिसमें जितने भी नंबर ऑफ वर्टिसेस हैं सारे वर्टिसेस रिमेनिंग ऑल वर्टिसेस से कनेक्टेड होंगे. हियर एग्जांपल ऑफ 4 वर्टेक्स ऑफ कंप्लीट ग्राफ, वी टेक 4 वर्टिसेस, vertex 1, 2, 3 and 4, and each vertex connected with remaining other vertex. V1 is connected with V2, V3 and V4. Same, V4 is connected with V1, V2 and V3. V3 is connected with V4, V1 and V2. Means every vertex is connected with remaining other vertex. Then this graph is known as complete graph, and the symbol to represent this graph is used K. If we use 4 vertices complete graph, then K4, and N represent number of vertices in a graph, and symbol K represent complete graph. If complete graph of 4 vertex, then we write K4 as shown in here, K5, K3, there are 3 vertices and each vertex with connected with other remaining vertices, then this graph is known as K3. And if we take K5, complete graph of 5 vertex, there is a formula used to find out number of edges between in a complete graph. Is the formula, that formula is E equal to n minus 1 by 2, means if n equal to 5, then 5 into 5 minus 1 5 minus 1 by 2, that is 5 into 4 by 2, that is 10. Then 5 vertex complete graph have 10 edges. We draw that graph. 5 vertices, edge 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Here, this is a complete graph of 5 vertex in which number of edges are 10. Number of vertices, as we know, 5, and degree of each vertex in complete graph is n minus 1. Degree of this vertex 1, 2, 3 and 4 edges are incident at this vertex, then degree of this vertex is 4, this vertex is 4, this vertex is 4, and K5 has a degree K4. And other important point here is a complete graph is also known as regular graph. Regular graph. Regular graph mean definition of regular graph: if there is a graph in which all the vertex have equal degree, all the vertices in a graph having equal degree, then the graph is known as regular graph. Next, cycle. Cycle of they represent a cycle with symbol C. If there are 3 vertex, then this perform a cycle with edges 3. If 4 vertices, then there are 4 edges between them. Then number of edges and number of vertices in a cycle are equal. Then this is known as cycle. Consists of vertices and edges. If each vertex are perform cycle. K5, if you draw K5, this is a graph, sorry, C5, 5 vertex cycle, then vertex 1, 2, 3, 4, 5 and edges 1, 2, 3, 4, 5 edges are there. Next topic, wheels. Wheels represent with symbol W and N represent number of vertices in a wheel. Wheel obtained by adding additional vertex to Cn and connecting all vertices to this new vertex by new edges. Means if we take a cycle of 3 vertex Cn and we add a vertex between them and connect with all remaining vertex, then this cycle become W3. Thank you. We will continue with other topics in next video.